My name is Martin Prodanov, and together with Tim, we will give you a presentation on IoT and big data, and in particular, how do we deal with data in the Cumulocity IoT platform. While Tim is getting wired up, I will give you an introduction of what are we going to talk about. So we start with a brief introduction of what of the data, where the data in IoT is coming from. Then we discuss the internals of our operational store, and we discuss how do we realize it technically. And then we focus a little bit on the new improvements that we have, Jürgen already mentioned in the core, in the platform that we have implemented towards time series. And Tim, we're going to take you to the data hub improvements that we have also implemented, and with regard to offloading and different use cases for data hub. And at the end, we have a small Q&A round and a conclusion. All right. So when we think about the data, it's important to first ask the question: where is the data coming from? So IoT, as we learned already, it's here for stay. It was maybe a buzzword a couple of years ago, but now it is very much present nowadays. And the things and devices, they have evolved. They are very, very different in their kind. So we have some, let's say, consumer IoT applications, like all of the wearables that we are wearing nowadays. We have cars that are maybe something in between consumer IoT and manufacturing and industrial IoT. And we also have the web of sensors that are being connected on a daily basis, that are maybe smaller but also generate a lot of data. And we have complex machines like robots and wind turbines nowadays that also are kind of a thing and a device and generate data. So it's a whole ecosystem of, let's say, simple devices to complex devices that can generate a lot of data, and we as a Cumulocity have to deal with this, all types of data and all types of devices. Of course, devices can generate all types of data, but it's important to differentiate between two types of data. On the one hand, we have something that's more irregular updates of a device, something that happens on an event basis, like device status updated. What is happening on the device? Something has changed, a relay has changed its state, so this is some kind of a irregular update. And on the other hand, we have what we call measurements data, which is a continuous stream of data. We have this continuous values of sensor data that's being generated. And this is also characterized with as a time series data. So normally those values are numeric from nature, but you have kind of a metadata attached to it, so which sensor or device has generated this data. And it's important to distinguish between those two types of data because they come with different challenges. On the one hand, the device status updates and device optimization are more like, let's say, less structures. On the other hand, we have big portion of the data which is more or less structured, coming in regular time intervals, and we can approach those two types of data with different solutions, and we can store them differently also for better efficiency and better scalability. At the heart of the Cumulocity IoT, we have the operational data store, and this is where we are storing all kinds of various data assets, from user representation and device representation. You as users of Cumulocity can maybe recognize some of those data types. I'm focusing here on 4 of the main data types that we have. First one is the inventory or device representation. This is everything that metadata representing a device, how many child devices this device is connected to it, etc. On the other hand, we have something that is more or less domain specific for Cumulocity. We have an events, we have an alarms, and we have also measurements data. So in our domain model, data model in Cumulocity, we distinguish between events, which are more something that's also irregular, when something happened and you want to indicate to the platform, okay, there is something, an event happened from the device, like something has changed, a parameter has changed, or there was a update installed, or there's something that's happened and that's important for your applications. Alarms are also something that maybe went wrong and the device, either we notice it in an application or either the device itself notices there is something wrong and we have to be informed for it. And of course, we have the measurements data, which is the continuous stream of the sensors data, and this is clearly the elephant in the room. This is by far the biggest source of data that we have in Cumulocity. And this is where we have to, maybe take a closer look at it, because this, as I mentioned previously, it's a continuous stream of data in a time fashion, and this is where we can do some optimizations. The other three data types, like inventory, events, and alarms, they happen on not that regular basis, and they just don't basically account for that much of the data that we have to deal with. It's also important to mention that the operational store is it's this in the middle. It's an object store. So we represent the data as a JSON. You can see it also on the screen, and we store it in a object database, MongoDB, and that's also quite important that when we take a measurement, we store it as an object, and maybe that's not the right representation for this time series measurements data, and that's why with Cumulocity 10.16 we started to look into various options. How do we can maybe be better in representing and storing the measurements data, especially for time series. Cumulocity had also built-in support, also in previous version support for time series, and the way that we can put the individual measurements together in a single document. So everything that was taken together, it's put together and stored together. But we realized that that's not enough. So we have to go one step further, and we want to implement further improvements and be able to really squash more measurements into a single document together. With 10.16, we implemented an advanced support for time series, where we focus, instead of individual measurements and individual data points taken together, we focus more on data streams, on time series data streams over longer periods of time that are, of course, grouped by device, but the focus is slightly changing. So we are, instead of storing individual parts, like you would say like in a row from a traditional relational database, we are storing them all in a columnar fashion. We take the whole stream of measurements that we have received for a single sensor or a single data series, and we put it together for a bigger portion, for a bigger time period. This is what we call buckets. So that's the illustration in the picture. So we bucket individual data points and measurements together into a single big document, so we can achieve, let's say, more normalized data model, and we can have less redundant data, because there is always kind of metadata that you have to persist anyways, like what type of measurement this is, which device is responsible for this measurement, etc. On a brief scale, what we have is like we reduce our costs significantly, and we also reduce the I/O, because we have to read at the end less data in order to process API requests or visualize the data in a dashboard. To be a little bit more technical here, this technical track, I wanted to show you the difference as an example. So on the left-hand side, we have what we, in previous version of Cumulocity, without the enhanced time series support, we basically take one measurement and we store it together with its source, okay, what type of measurement what is the actual data point, the unit, and the actual value. And when you look closer, the difference probably in those two documents, it's just the value. That's the only difference that can happen. And what we have done is we changed the data model a little bit, and we are putting, basically separating the data, the thing that changes more frequently, from the metadata that is more static and can stay there, and we put it together. So that's why we have separate parts for data and metadata, and the values are basically in a continuous stream right now that is ordered implicitly by time, and there is also, of course, time granularity. At some point, we will start a new bucket and we will start a new document where we put measurements together. All right, let's have a more detailed focus on what are advantages of this improvement. First, we want to have better scalability, so we can handle new use cases and more demanding use cases where we have more devices, more data coming in. And we want to reduce the hardware cost, of course. Since modern disks are pretty much expensive, they are fast, okay, that's good, but they also cost a lot. And the data that we collect, it's maybe not that valuable after a certain period of time, and after a couple of weeks, we basically are going to pay for something that we don't need that much. And reducing the disk size here, and by compressing the data together, that's really valuable. On the other hand, it also offers new possibilities and new ways to, new use cases that we can implement on top of this, like aggregating data together. Maybe the measurements that I have taken today are not that important after 1 week. Maybe it's the week average is important to see after 1 week. So that's what it's called roll-up typically. So you get historic data and you roll it up together. And since this is numeric data, maybe a simple average of this time series per hour or per day, etc., it's enough to have. The metadata is constant in its use basically for searching or for grouping. It also offers us to basically make the applications more powerful. The dashboards can visualize data over longer periods of time like this. And if we like, we can also train some machine learning models based on this data. If we have it for a longer periods of time, we don't have to always offload it, and maybe it is enough to, if we want to predict something that's not that that's important maybe from the newest data. If I want to predict something that's important for today or for tomorrow, where I don't need to scan the whole year of data in order to train the model, that's also would be possible to use more data directly from the operational data store. There are, of course, also downsides here with, sorry. Of course, there are also some trade-offs when we do such changes about the data model. It is a bit more complex, yeah. We are not talking about individual measurements. We had to change the data model We had to change a little bit the way how the APIs are behaving. Yeah, we have to deprecate a couple of endpoints, so you cannot look at individual measurements. Now, in older versions, you can take measurements, a single measurement, and you can ask for it, but there are rarely use cases for it. That's not that important. But anyway, and yeah, there are additional challenges like dealing with out of order, late arrivals, exactly, and yeah, also additional challenge is that what do you do with faulty measurements? Today, if you send a measurement and then you realize, maybe that was some wrong, the device had some errors or whatever, so I want to get rid of this measurement, so I want to override it. That's a bit more hardly possible right now. But yeah, so we have the trade-offs against this lower cost and yeah, individuals. Like this illustration with the SD card, so you can put all your music library on the SD card, but it's harder to find, and if you have it on a CD, so you can check the correct album and you can find it easier. All right. And I think I hand over to Tim.
Yeah, thanks, Martin. So first of all, great to see that you all are more hungry for cool tech stuff than for food, but the clock is showing 20 minutes, so there will be some food soon. My name is Tim Dörnemann. I'm one of the architects of Cumulocity, and in particular, the architect of Data Hub. Does this sound good? Sounds strange to me. Okay. Yeah. So first of all, quick poll: who of you is actively using Data Hub already? Okay, quite a lot. And who has never heard about it yet? Okay, a few only. Great. So we can go a bit faster, I guess, with the introduction. Yeah, so Data Hub is an add-on component to Cumulocity Core, and it has two high-level use cases. The first one is it allows you to extract data from the operational store, which Martin talked about, from MongoDB, and persist it into your data lake. So it's a data lake you bring, and we extract the data there, transform it to a format which is more suitable for analytical purposes. And then use case number two is it enables you to query the data you have previously exported via standard SQL. So just like with a relational database like Postgres, MySQL, or whatever. And for the first use case, the data extraction use case, we obviously need to read the data, and we do so by directly accessing the operational store, as you can see there. And then the data is transformed and written to a data lake. And then for the second use case, for the data query use case, we do support various interfaces, ODBC, JDBC, and REST, and also have connectors to other applications from our suite, like Trend Miner for time series visualization, and also to our machine learning capabilities. So the data extraction basically operates using a central cluster that is deployed, and you can see those narwhal icons there. That's a tool called Dremio that we use for that. And then you have a per-tenant microservice, so you can basically decide on a per-tenant basis whether or not you want to use Data Hub. And if you subscribe to it, the microservice schedules regular data extractions. The default interval is once per hour. And what basically happens is that we read all the data for the tenant that has arrived since the last offloading run. Then transformations happen, and I will talk about that in more detail in the next slide. And then the data is stored as Apache Parquet files, so nothing proprietary, but an open format that is used by all big tools like Spark, and also even engines like Snowflake nowadays have extensions to read Parquet files directly. Or you can read Parquet from Python and so on. So we do support a variety of data lakes, as you can see on the bottom. The obvious ones are S3 and Azure Storage, whereby Azure Storage has Gen 1 and Gen 2. Gen 2, we support both of them. And then for, especially on premises, we also support Hadoop file system, the HDFS. And then also some S3 compatible, API compatible clones. There is Wasabi and Minio. And as you maybe have noticed in the A1 presentation, also Exascale. And there are others too, like the Tencent cloud storage, which is compatible. We have qualified that. And the same applies to Oracle and a few others. So as Martin has already said, we have different asset types in Cumulocity. And for Data Hub so far, 4 of them are relevant. First of all, alarms and events. Then inventory, whereby inventory can be device data or group hierarchies or customer-defined managed objects. And the elephant in the room, as you said, like 98% in terms of data volume is measurement data, time series data. And there's 2 other types, sorry, I skipped over that. 2 other types, operations and audit logs. They are currently not supported by Data Hub, just to take that question already, but it's a roadmap item. It will be supported sometime in the future. So the task we need to accomplish when extracting data from MongoDB is we need to translate from the internal representation on the left, which is clearly deeply nested JSON, to a tabular relational structure like you can see on the right. And here we have a made-up example of a waste management system or IoT solution where the interesting data actually sits here. So we have actually 1 fragment and 2 series. So the fragment name is waste, and then we have temperature and weight as series. And we want to translate that into a tabular format because that's very much suitable for BI purposes, for machine learning and so on. It's better, you can handle that better than in JSON. And some of the fields are really easy to translate. So like the top level JSON fields, they are just translated into columns on the right. But for that JSON structure down here, we basically need to unnest it and have chosen a dot signature here. So we then store those as columns like waste.temperature.unit, waste.temperature.value, and so on. And so then the data is flattened like that. And you now might think this is complicated. It is, but only internally. We have a built-in very easy-to-use UI. And in case you don't need to configure anything special like filters or custom attributes, it's 5 mouse clicks that you need. First mouse click is create offloading configuration. Then you get to this wizard here. And then you have to choose which collection or which type of data you want to offload. So here I have chosen measurements. That's click number 2. Then I click next, click number 3. And then click number 4 and 5 is to select which measurement type I'm interested in case I have more than one. And then I click finish. That's 5 clicks. And then you have your offloading pipeline defined. And from that point on, data is regularly offloaded into your data lake and available for downstream analytics and processing. Yeah, and the second use case is obviously to query the data you have previously exported. And as you can see on the top, we support many tools. And actually, this is only a selection of tools because the technical requirement is just that your application can either talk REST or ODBC or JDBC. So pretty much every application should be able to connect with one or the other interface. Very often used, of course, are tools like Power BI and to some extent also Tableau and Python, Java, and whatever language you choose to implement your microservices. And REST especially is important for UI applications because it can use the authentication information from an active Cumulocity session. So the logged-in user is then used as the authentication user for the REST API, which makes the whole integration into Cockpit and so on very easy. So how does that work? You basically either need to write a query. If you are in a programming language, then you just need to write the SQL on your own. Or if you have Power BI or whatever, then any changes you make to your dashboard, if you drill in somewhere or whatever, that will then generate a SQL query that is sent to Dremio, and then the internal processing will start. In that case here, I have decided to use a very simple example. We want just to calculate the average temperature per month from our waste management example. So the query is submitted. Then we need to determine which data we need to read from the data lake. And here it's important to reiterate that Apache Parquet is in column-based format, so we don't need to read the whole rows, which can be quite long in terms of columns if you have multiple series. But we only need to read what you actually need. In that case, that's only 2 columns, time and temperature. And then the data is retrieved from the data lake in parallel. That's also important to note. It scales horizontally in the number of available CPU cores. And then the data is processed. In this case here, simple average is calculated. And then the result is returned to the application. Very easy, just behaves like a database, at least in terms of reading data. Okay, now I want to quickly talk about a few best practices, and then I will highlight 2 roadmap items that we think are pretty interesting. So best practice number 1 is you can, instead of looking at your raw device data, which might be second or even sub-second resolution, which might be hard to visualize because you have like millions of data points and only so much screen real estate. So instead of looking at the raw data, you can use Data Hub to compute aggregations. In that example here, I'm doing hourly aggregations, computing the minimum, maximum, average, standard deviation, and so on per hour. And you can either just do that via a SQL query in your application, or again, just like in a database, you can also create a view, and then you can just query the view, and the whole computation is then done internally. So you don't have to repeat that all the time, but you store that view in Data Hub, and then you just query it as if it were a table. And then, maybe it's not that easy to read that, but you can deduce from the different colors. We can now easily visualize minimum, maximum, and so on, and on a different time granularity. The next best practice is actually more like a warning or a hint, honestly. You should try to keep your device data as clean as possible. Clean in that sense means that you should not mix up data types for the same attributes. So here's a very simple example. I have 2 managed objects, 2 devices, and they both have one custom property, myprop. And device number 1 sends a JSON object, a:1, and device number 2 sends a string. In a relational database, as most of you know, that doesn't work. In Data Hub, it does work. We will offload the data, and in the data lake, we will then have a so-called mixed type, so a mixture of a JSON object, a struct, and a string. That works fine until Data Hub 10.18, which is to be released soon. You can do stuff like select myprop.a in that case, but it will only return the value of 1 for the first row. For the second row, it will return null because the second row doesn't have that property. And if you have a table like that, it doesn't really work well with analytical tools like Power BI because they just cannot handle that type of data. In 10.18 plus, that's a breaking change we have announced earlier. That kind of data would automatically be converted into a string, so it's easy to handle that, but harder to work with because you cannot drill in then anymore. There's ways to work around that, either to have clean data at the ingestion side, or you can define custom operations in the offloading wizard to make sure that the data is separated into different columns or cast into a string or whatever. But this is so important that I thought it's important to mention that here in front of the audience, because this is one of the mostly seen support requests that we currently get. But now to something more positive, I guess, roadmap items. We have two things we are very excited about. The first one is query federation, or we internally also call that live view, or the new shiny term for that is zero ETL. So the high-level idea here is that we will provide an abstraction layer both on top of the already extracted data lake data and the data which is still sitting in the operational database. And you will be able to just run one SQL query against that abstracted view again. And it will then internally fan out into two separate queries. One will fetch the data which has not yet been offloaded from the database, transform it, as seen before, from this document-based structure and the table structure. And then it will fetch the remaining required data from the data lake and merge the results. You can see that in the table here we have two greenish and two yellow rows, and they come from different sources. The yellow one is the data lake and the green one is MongoDB. And that will enable new use cases, make visualizations in the Cumulocity UI much more easy to implement, because then you don't have to query two sources yourself, but instead Data Hub will do it. And the other feature we are quite excited about is Apache Iceberg. And I think they should actually have called it Apache Ice Cream, because many customers are asking for it. It really sells like ice cream. Iceberg will add additional capabilities to the data lake side of the solution. It will, first of all, bring asset transactions, so transactional behavior. It will enable use cases where you can then insert into, again, like in a relational database. It will allow update and delete operations on data in the data lake. So it will really turn it into something very, very close to a relational database. And then also features which are more interesting for us as R&D. As an example is partition evolution, which means that we will be able to dynamically, based on the amount of data flowing in, be able to change the granularity of how we partition the data in the data lake, which in short has massive performance impact. So if you do it right, performance is good for queries. If you do it wrong, it's not that good, obviously. And that will give us great capabilities there. Yeah, and that's all. We are open for questions now.
All right, any questions?
So my question is a bit basic, given all the functionalities that you have presented. I had a customer request now, which we tried to solve with the Data Hub. The problem there was that you basically force the transform on the data, right? There isn't, and what the customer wants is a simple extract. What would you recommend there? Just to extract the raw data and store it somewhere?
You mean the raw data in terms of a one-to-one copy of the internal data
measurements,
structure?
Managed objects, events.
So actually we don't perform too much of translations, at least for alarms, events and inventory. But for measurements this is necessary, because at least for the legacy data format, the internal structure is just not usable by downstream applications. But we could certainly talk about that, because we already store the intermediate results in the data lake. But during processing, while the offloading process is running, we delete the intermediate steps, basically. So I guess all you are asking for is to keep the intermediate state as the source for the customer, right? So I guess we can take that offline. It would be interesting to understand why they really want to have the raw data. But
they want to have, basically they want to have all the data, because they cannot commit now to which exact measurements they want to have, or which exact events, and which custom fragments from that, because the custom fragments may evolve in the future. And so they don't want to commit to these jobs, to configuring the offloading jobs, because they don't know if they will not change potentially.
Okay, so I guess we should take that offline. That's a different thing than I understood. Yeah. Okay.
Question to Martin. On the time series, on slide 7, I noticed the transformed measurement doesn't have timestamps. Why is that?
And that's maybe on purpose put there. There is a time step, of course, for the whole bucket, and individual measurements do preserve their actual time steps for the moment. But there is a whole time step, and if you can see on the left example, there are 2 timestamps. On the right, there is a different one that makes less sense. Maybe it's like it's the first timestamp when you open this bucket and it doesn't change. But there are timestamps there also.
But when you query on the packets, you don't refer to timestamps in this?
You are referring to timestamps, but the query patterns are a little bit different. So
Okay.
you have to find this bucket, and of course you're using the time to find it.
So it has
That's
a time
there.
range. Yeah.
Exactly, you specify a time range normally, and depending on the time range, you also match documents. In the right-hand side would be normally 1, maybe, if it's a smaller range. On the left-hand side would be 2 or 3.
Okay. So this is coming on R16. When we upgrade on existing databases that has a lot of information, do we actually have tools to create these time buckets as well, or we don't? It just starts from when
you want to migrate an existing tenant to a time series tenant, yeah, there are a couple of ways already that you can do this. So you can, unfortunately, it's required to completely copy the data into a separate collection. And there are ways you can enable parallel writing into both to test whether everything works fine, and then leave only time series. And we're also working on solutions how to migrate existing, maybe bigger databases or databases that contain old data that needs to be preserved.
Right. Last question for Data Hub. When we extract information, we lose the access levels. Like these users can access the devices, this user cannot access. So how do you maintain these security levels when you extract information?
So you're saying that, let's say, defined inventory roles as an example are lost, right? Yeah. So we don't preserve that because the data is leaving the domain. So we extract basically from the Cumulocity domain into a data warehouse with different users. So it's hardly possible to keep that in place because you even don't use the same users to log in via ODBC and JDBC into the system. So we just cannot preserve the security information. One thing we are currently researching is that if you use the REST API, which then has Cumulocity authentication information, to preserve the authentication and the security, the RBAC stuff in that case, but we don't have that yet. But we are researching it because especially for the query federation case, that will be interesting. Otherwise, if you then build your visualizations, data becomes visible that the logged in user should not be able to see and so on. So we are on that, but this is really not trivial to solve, but yeah.